Welcome to ACT Prep's Unit 5 notes on the Pythagorean Theorem. We're going to do some work on dealing with both when you have a picture and when you don't, so hopefully when you look at one of these, no matter what format they're in, you're going to be in good shape, ready to go. Pythagorean Theorem. We've talked a little bit about this even earlier in the term a little bit. A squared plus b squared equals c squared, which in more of a mathematical sense we would call leg squared and leg squared. Okay? The two shorter sides of your triangle equal the square of the hypotenuse, your longest side. So in looking at this first part, and we're not going to look at them all on here, we're basically going to label the hypotenuse first. And the easiest way to recognize that, if you can't tell which side's the longest right away, is to go ahead, draw an arrow from your right angle over to the side opposite that, and that's going to be your hypotenuse. The other two sides right now are interchangeable. We call those the legs. So again, anytime you see a right angle, the side opposite that will be your longest side, your hypotenuse. And the reason for that is sides' lengths are directly related to the angles opposite them. Since a right angle is going to be the largest angle in any triangle, any right triangle, excuse me, the side opposite that's going to be the longest. And again, the other two will both be your legs. If you don't have a picture, like we do here, again, the longest side is your hypotenuse. The other two are legs. The longest side is your hypotenuse. The other two are legs. And that's the way we're going to sort of build our Pythagorean theorem problems off of. So again, let's say we actually get into a problem. Here, I'm looking for my hypotenuse because I have the two legs already. So, legs squared plus legs squared, and the order doesn't matter. If you had 3 squared first, that's just fine, equals x squared. Multiply those out, and again, make sure with your squares that you're not doing 4 times 2 or 3 times 2. 4 squared is 4 times 4. And the last little hiccup we could get into, when we get here, we're solving for x, not x squared. So when you get to this point, you have to make sure that you take the square root of both sides. You do that, you get 5. For those of you that have dealt with upper level algebra possibly, you might say, well, it's plus minus, but remember this is sides of a triangle, so a negative side of a triangle really doesn't make sense. We end up getting 5. Okay. Now example B, we could do the same thing. This time we have the hypotenuse though. Okay, here we just had 2 legs, but over here we have the value of the hypotenuse and the leg. Why does that make a difference? It doesn't really if we keep it in the leg squared plus leg squared equals hypotenuse squared order of things. So what you're going to be taking a look at here, okay, a little more work. We got to subtract the 576 from both sides. And then again, take the square root. And your answers won't always come out nice like this. Typically, we're going to go to the nearest tenth or the nearest hundredth, so you're going to want to read directions carefully to see which one you're supposed to be doing. But what we're going to take note of, and I'm going to move this up just so we can still see this as we're looking down here at the bottom. If you have 2 sides or 2 legs, let's be mathematically correct here, add their squares together and take the square root, just like we've been doing on examples A and B. However, if you have a leg and the hypotenuse, like we did in example B, instead you could take hypotenuse squared minus leg squared to equal your other leg squared. You still can do it this way, you'll get the right answer, but I'm just trying to give you an option for a possible shortcut here. So again, here I look and I say, okay, I'm looking for the hypotenuse. I have 2 legs. When I have 2 legs, we do it up here like we do example A. So leg squared plus leg squared equals hypotenuse squared. I either punch this in the calculator or I remember this from some things I've done before. Add those up. Take the square root. Get my answer. Keep getting all these answers come out nice. Need to find one that doesn't. Maybe number 2 will help us out with that. Again, I'm looking for the hypotenuse. I have 2 legs. So again, I refer back to letter A here. So I have 20 squared plus 21 squared equals x squared. So again, as you work through these, oops, ran out of room. We'll move up a little bit here now that we have the idea. Sorry about that. So what happens when I find a number and I go to punch it in and it comes out as a decimal? Like this one is going, oh, no it didn't. No it didn't. Harty looking silly. Going along with his own, still not getting oddball answers. So you start to look and you're like, okay, ooh, here I do have the hypotenuse and a leg. Okay, that's going to be like we do with letter B. Now, again, you could still do it this way, do it like we did up in example B. However, I'm going to try this new way. So I'm going to do hypotenuse squared, so big squared minus my smaller number squared. And as you start to work your way through some of these, you'll start to get the hang of it more. So 1725 is t squared. Let's see if this one comes out as nice as the other ones have. Okay, not so much. So this time, let me just write out some of the decimals we've got here. Now again, we're rounding to the nearest hundredth. So here's how this works. We know we're going to have 41. Tenths, this is the one that we're kind of taking a peek at here. 3, remember, when we're rounding, anything 4 or below rounds down or stays the same. This stays at 3. If, for instance, let's say this would have been 0.5381. That 8 would have made this round up and I'd have 41.54. The only number that's changing is that last one. So if it's tenths, it's this number. If it's hundredths, it's this number. And we got to be careful of those things. So just something to keep an eye out for. We're going to do one more similar to it up at number 7. Notice again, this time we have the hypotenuse that we're trying to find, but we have the two legs. So we'll take the sum of their squares. And if we add up 13 squared and 14 squared, you get 365, and again, square root. So for those of you that like being able to do the same thing, we keep getting to do the same thing over and over, which is kind of nice. So when you look on your calculator, see it says 19.1049. Now again, you take a look, you say, okay, I know the 19 is staying the same, I know the 1 is. This is the number we're trying to check out. 4 is 4 or less. That stays the same. It's those little detail things to try and keep an eye out for. So, okay, we've been doing some calculating to find a missing side. What if they give me all the sides like they do down below? Well, here's how this is going to work. If they give me all the sides, it still should work if it's a right triangle that leg squared plus leg squared equals hypotenuse squared. So again, I'll get my sides labeled. And what we're just going to do this time is we're going to let the calculator help us out. Leg squared plus leg squared equals hypotenuse squared. So I'm going to go ahead, I'm going to multiply that out, and then I'm going to add my two leg squares together. We'll do the two sides equal. If it's a right triangle, it should. But these do not. So this is not a right triangle. We have an imposter. We don't like imposters. They're no good. So let's try it again with another one here. Hypotenuse in my legs. So 20 squared plus 25 squared equals 28 squared. 28 squared, I even got to double check myself here. 784. Not looking good here again. Okay. You're like, are any of these ever going to work? Well, let's check. Let's see if this last one does. So my legs are 24 and 45. Whoops, equals. Try and quicken things up a little more this time. And this time the two sides match, so this is a right triangle. Okay, two sides equal is a yes, both sides don't equal to no. This is not one where you just write yes or no with no backup work, because then I'm going to think you're just up to something and trying to get out of doing work. Okay, so as we head towards the bottom, it's the exact same concept, except now there's numbers there instead. So when I go to do one of these, let's say we're doing 12, my smaller numbers are the legs, the biggest one is the hypotenuse. And I even remind you of that right here. So legs squared plus legs squared equals hypotenuse squared. And sometimes the order is going to get mixed up, so you can't just do the first two squared together every time. It might not necessarily work out for you that way. So if I multiply this one out, the two sides equal, and yes, I would have a right triangle. But like I was saying, and I'm not going to complete them, but I'm going to make sure we set them up right. Like in number 13, the hypotenuse is 110. So I square the two smallers and set them equal to the largest. Here, 26 is the largest number. I square the two smaller ones and set them equal to the largest, and then calculate it. Okay? And finally, this is just kind of a for your information down at the bottom. Pythagorean triples, some numbers that'll work every time, sort of like 18, 24, and 30 happen to work here. These are some smaller ones that work every time. So if you happen to see them, you might be able to get to your hypotenuse or a leg if you're trying to find it a little bit faster. Hope you've gotten this one all right. As always, if you have any questions, let me know.